Hello everyone, this is Mr. Manmath Nath, Assistant Professor, Department of CSE Cyber Security, Data Science and AIDS. Welcome to the class. Today we are going to discuss something in the tutorial, that is searching in AI. As in the previous classes also we have already discussed how searching is playing a very vital role in AI. Today in this tutorial we will discuss what are the different types of searchings. Just an overall, not into the details, but we will see the broad things about searching in AI. So let's start the things. First thing is that why searching is necessary in AI. Suppose some problem I have been, just we can take an example before going into the details. Suppose I have written something in the prompt of the ChatGPT. I have given some queries for that. Then what it happens exactly, the machine takes the questions, converts it, understands it, then try to find out the need that I am asking for. Then it tries to search in its knowledge base. Whatever knowledge it has, it is trying to search in that one. Then after searching, it is giving me a response to that one. But there is a chance that whenever it is searching, machine is searching in its knowledge base for my solution to my questions, it may get more than one solutions also. But AI is playing a role that whenever it is getting more than one solutions, it tries to find the best solution for that and giving me the answers for that. For that, searching is very much necessary, and a proper searching in proper place, that is more important. It's not that any search you can use it everywhere. So depending upon your inputs values, depending upon your need, depending upon your requirement, depending upon your feasibility, you have to choose a particular type of searching algorithm. Whether, as we have discussed some of the names like BFS, DFS, best first search, UCS, A-star algorithm, DLS, like this. You have to find out which one is the best one for your reason, for that, your purpose. Okay, now let's start with a simple question. I am starting from a place, that is, let's take it from my home, and my target is to reach at the, suppose this is my home, and I am supposed to reach at the college, that is VNR college. Fine, and I am staying somewhere 2 kilometers away from that. Now I don't know which is the correct path in that case. In that case, I must explore it by using AI. For example, suppose I may go to GPS also. Whenever I am going to GPS, AI is just taking the multiple possible paths. Suppose this is one path, this is secondary path, this is the third path. And these all are known as the search spaces. It will explore all the search spaces. Then from all those three, it will find which one is the best and the optimal one. Which one will cost less, which one will take less time to reach at my objective. So these are the best possible routes, and AI will explore all these things and to get it. So how to do it? Here the searching comes into picture. Fine. So let's see why AI needs searching. There are basically different applications may be there. For example, it has been given route finding. From one source to one destination, there may be multiple routes are available, and I have to find a proper route, a best route out of that. Suppose a game playing is that. Game playing is nothing but a movement of different objects in different ways for different types of movements. I have to just play the games to reach at my objective. Either suppose it's a firing game, bullet firing, I am supposed to fire the thief. Fine. In which way I should go so that I can reach at my position, I target, like that. Then robot navigation. Now it is the best, one of the best example, and mostly in every hackathon they are using this one, robot navigation. Whenever from one place the robot is moving to another place, there may be certain obstacles are there. When robot is suppose moving, how it is identifying that this is a obstacle here, and here if it is finding some obstacle, it is also taking a decisions how to overcome this and go to the next step. For that it is using AI. Puzzle solving, so many different puzzle games are there. Like the best example is that you can say 8 puzzle. I think most of you are very much well acquainted with this one. 8 puzzle game. 8 puzzle is the best example of AI. It says that, like suppose 8 puzzle game is that this is one position where 1, 2, 3, 4, 5, 6, 7, 8. Now I have some target to make it 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my initial state and this is my goal state. Fine. From this I have to reach this one. But from first one to the next, I may have multiple solutions. Like in one, it will be 2, 3. Here 1 I can bring it 4, 5, 6, 7, 8. In this one I can move this one, that is 1, 2, 3, 4, 5, 6, 7, 8. And the third one, there is a possibility that I can have 1, 2, 3, 4, 5, 6, 7, 8. 3 possible ways are there. In this case, it's a puzzle. Which one is the best one? There AI helps me to just go for the navigation. This one is the best one, or this one is the best one, or this is with all the 3 alternates are there. Then AI helps me to choose a best one only. Then planning and scheduling. These are also some other activities then where we can use AI for by using the searching algorithm, searching data structure. Now, what is a search problem? We are starting at some position and we are supposed to reach at some position. If there are multiple ways are there to explore, in that case, I have to search which one is the best way and to reach at my goal only. Fine. Now, the biggest challenge is that if I have a very small problem, but that will create a very large number of search spaces. In those cases, what to do? Suppose there are 1 or 2 multiple choices are there for a particular problem. Comparatively, it is easier. But wherever there are thousands plus, like this says that, suppose there are thousands plus alternates are there. In those cases, it's very difficult. For a normal human being, it is not that it is impossible, but they can do it, but they will take a lot of time and lot of effort is required. Whereas AI, if we are using AI there, within a fraction of second, it has the capability to make the solution, to find the best solution for that one. That is the difference between man and machine. Man, every human being has a limitations in every resources, but machine has more resources, more ability, capability is more. That's why it is being differentiated in different categories like narrow AI, strong AI, and super intelligent AI also. Fine. So here in these cases also we need some systematic and strategical methods to do the searching, and which searching is appropriate for which one, that we have to look for, and that if we are using it, AI can help us like anything. It will find the best thing in best time, and it is very much optimal, and the decision making is perfect always. Fine. Now, what is for going into the searching data structure, we need to write some algorithm every time. So algorithm is what? Simply these are the steps, how to do the work, how to process with it. So which state should the AI explore next for any current state? Something is there, then what are the next alternate states and which one I need to explore it? For that I need to just take care of few things. That is, I need to check with each and every cost factor, each and every time complexity, space complexity, heuristic, maybe the cost factor may be a path cost, may be a heuristic cost also. But we have to take care of everything and evaluate it. Then as per the evaluation only, we have to find which one is the minimum cost and we have to opt for that one. That AI is playing the role there. It is helping us in exploring the things. What next to do? Then there are different AI search strategies are like BFS, that stands for breadth first search, DFS for depth first search. BFS is going label wise, here it is going column wise, that is depth wise. Fine. Then next is DLS. DLS is an advanced version of DFS with some limited number of depth is there. Then UCS is a cost factor related search algorithm. Best first search and A star algorithm, these are the two heuristic algorithms, where in best first search it is only following the heuristics values, where in A star algorithm it is following the path cost as well as the heuristics values, and it overcomes some of the demerits of the best first search. So it is not that any single algorithm is the best one. Different algorithms are meant for different purposes. We have to choose which algorithm is best for which requirement, which task, depending upon the feasibility and the need of the problem statement. Ultimately, you can say, what is the big idea? The big idea is that AI is often not just about finding a solution, but finding the best solution. It is about finding a solution efficiently. That efficiently word plays a very big role in saying that AI is perfect. How it is said that it is efficiently? It mostly avoids unnecessary explorations. It helps us in avoiding unnecessary explorations. It helps us in using available information intelligently. Intelligently means whichever is required, simply we are going to use it. Whichever is not required, we are supposed to skip it. We are saving the memory there, as well as we are not exploring the useless things. Something is not required, so we are saving our time also in those cases. Time and space, both the things we are saving. So from all these things, we are finding the best solutions with respect to quality, time and memory. There is time complexity, space complexity, and the quality. It matters a lot. The quality should be good one, where AI is helping us. And this is the big idea that you can say the word efficiently. It is the most important word, rather than finding a solution. Finding a solution, many persons can do it, but finding an efficient and good solution is very much important. Okay, now whenever the search strategy AI is using it, we are facing some questions. Should I explore it broadly? Broadly means, suppose it here it is a search tree is there, suppose. Fine. Should I explore each and every node to reach at my goal and to check that whether I reach at my goal or not? That is called one type of work, that is called global search. Fine. Or should I go for a local search? Local search means, suppose one part I am exploring it and my goal is here. It depends on different situations. So the second one is that, should I go into the deep? Suppose I have started from here. Should I proceed till it is completed, then I can backtrack, or should I break in between and come to the right side, to the neighboring or the shallow nodes? It matters. Then should I consider the path cost? There are different costs are there. Suppose from reaching from A to B, there may be some path cost. Suppose path cost is 8 here, path cost is 7 here. This path cost says that how much you have to spend when moving from the node A to B. And is there any heuristic cost? Heuristic cost says that, suppose this is my goal state G. From every node to the goal node, there is a given heuristic value is there. Heuristic means your imaginative value. Suppose in a real life example, I can say that, suppose I am starting from here. I am supposed to go to JNTU, to reach at JNTU. Fine. So whenever I am going from here, and I will just opt for a auto, I think that I will opt for a auto. And I have seen that if I will go for the auto, my tentative price, that cost that I have to pay is 100 rupees. Suppose I will opt for a cab. Or same auto also in different routes, my tentative estimated price will be different. Those are the heuristic cost. Those heuristic, based on those heuristic cost, is it that I will make it as a parameter to choose the best path or not? For heuristic cost, there are different algorithms, like A star algorithm is there, as well as your best first search is also there. Fine. Some other algorithms are also there, AO star algorithms. Then another is that whether I will include both path cost as the heuristic cost. Only path cost, it is applying the algorithm that is called best first search. Sorry, it's a mistake here. Here it is a BFS and DFS. BFS and DFS. Here it is best first search. This one is a example of A star search algorithm. A star search, like that. For different purposes, different inputs, different feasibility, we are having different algorithms. Fine. So now it's a big question that leads to another question, that which algorithm should I follow? Suppose for the same heuristic part, there are n number of algorithms. Or suppose for like BFS and DFS both are there. It comes under one category. Then which one I will opt for, BFS or DFS? That becomes a big question. Fine. Now, this is the algorithms that we have already discussed. Some of the names that it has been given. Fine. Now, this is an example that I know where I am. I am here at the start position. This is my initial position. And this is my target, or that is known as the goal position. Now, I know I have to go from start to goal, but I don't know whether I'll go on this way or I'll go on this way. This becomes a bigger question. This becomes a bigger query, whether this one is a good one or this one is a good one. There your decision making comes into picture and AI plays the role there. Fine. And we have to go with the different search, and based on the search output only, that is the evaluation values, we have to decide that which part we have to explore it. Then what is the search in AI? Search is a systematic process of exploring possible states to reach a desired goal. Fine. An AI agent means a particular thing that helps you in doing the work, processing, and that is known as an agent. AI agent starts from the initial position, initial state, and applies actions to generate new states. Suppose this is one position I am starting, this is the next state, immediate state. This may be a goal state, but this is the initial state. Whenever it comes to this one, then it is the new state, current state. Fine. The agent must decide which state to explore. Every current state it is there, it is finding alternate routes, and it is finding the option for that, which or whether I will opt for this one or this one, and making the current state some other one. Suppose it is moving here, the current state will be changed here. Find that. So different for this thing, it is applying different searching algorithms for making the choice or taking the decisions for that. So the flow, we can say it like that. It starts from the initial states, actions are there, then it's generating new states, then finally it is coming to the goal state and reaching the objective for that one. Fine. In this case, there are some terminologies or the elements that we are using in such problem. First one is the initial state, where we start. Then actions, operators, that is the possible types of movements from one state to another state. Then state means a current situation. The configuration or the situation of a particular node is known as the state. Then the goal state is the target one or the objective, the final state, that is known where we are supposed to reach. And the path is the way or the sequence of states or the actions, the way that makes us reaching from the initial state to the goal state. And the cost is what? Path cost is what? How much we are paying for traveling from or traversing from initial node, initial path state to the goal state. How much we are supposed to pay it. That is known as the path cost. That helps you in deciding whether this path is good or that other path is good. Okay. This is one example. One possible way is ABD. Then another is ABE. Then ACF. Then ACG. But if my goal state is this one, I may choose this one. I may choose this one. I may choose like this. I may choose like this also. Directly ignoring this one. So there are multiple ways are there. Fine. So we have to explore each and every way, and like this we have to write each and every path. Then we have to find the path cost. Then we have to decide which one is the best path to opt for. Now, the key question in searching is that which nodes should the AI system explore next? It depends upon the restrictions or the constraint you have. It depends upon the algorithm that is having some what type of input values. Depends on the methodology, whether you are going level by level or deeper level, horizontally, vertically, or you are considering the costs or the heuristic path cost, or both path cost and heuristic. It depends on that parameters based on which you have to decide that which algorithm should I follow to explore the next state of my current state, and I need to reach at my goal by using the AI systematic approach on that one. Okay, then there are two terms are there. That is one called search space and another is called search tree. Search space is what? It is all the possible states that is available in the tree. It is not connected. Simply, which are the search spaces? Number of spaces available for searching: A, B, C, D, E, F. If we are connecting it, then it becomes a tree here, and this tree is known as a search tree. The search tree represents the sequence in which the possible are being explored. But if we are not connecting it, giving the lines, it is difficult that whether A is connected to B or A is connected to D, or I cannot come to know that. But it is only the availability of the things. But here it is bringing a configuration or a network or an architecture of this one. So this becomes known as a search tree. This is a state space search. Now, there are basically two types of searching here. One is informed, another is uninformed. As normally the informed word says that some hints are being given to you whenever you are doing the searching. Some points are being given so that one help you in doing the searching. Then it comes under informed search. If nothing is given, simply you are supposed to search it. That is otherwise also called as blind search. It is otherwise also called as blind search. That is known as otherwise uninformed. Another technical word is uninformed search. If some information is given for the searching, then it is called as informed search. These are the algorithms that is coming under uninformed search category, and these are the algorithms that is coming under informed search category. Okay, then in the coming days classes, what we are going to learn in details, first one is that we learn BFS, breadth first search, then depth first search, then depth limited search, then path costs related search, then only heuristic one, that is best first search, then heuristic and path cost related, that is A star search. For every search there is some advantages, some disadvantages are there. We'll just see which one is the best for which particular type of situations and the environment. Okay, now let's have a quick recap of all those things that we have already discussed. First one is the search, find a sequence of actions from the initial state to the goal state. What is search that we have discussed? Then what are the different searches states, like actions? What is a goal state? What is the initial state? What is a path cost? And all those terminologies that we have discussed, that is already there. And the main difference we have discussed is that how to explore the next node after the current node. There are multiple ways are there, multiple solutions are there. How to explore which one you should go for, that we have already discussed. And in details, when we are going to discuss with the next algorithms in the next class, we will discuss about the breadth first search. Okay, thank you very much.